children, second chapter of physics is motion in one dimension, or it is also called as motion in a straight line. Here you need to learn about the different frame of reference. Okay, that means from where we are taking the measurement. Then what do we mean by straight line motion? Some concepts of differentiation and integration. Okay, then there are two types of motion, uniform and non-uniform. Then all instantaneous velocity. For instantaneous velocity, we depend on differentiation. Then uniformly accelerated motion and velocity time and position time graphs. And from that, we need to find the relations of uniformly accelerated motion, that is 3 equations of motion, along with the distance traveled in the nth second of motion. So this much we need to cover up in the chapter motion in a straight line. Okay, so we start with what exactly we mean by motion. Any object is said to be in motion only if the position changes. When the position of an object changes, we say that the body is in motion. Okay, and if the position is not changing, we say that the body is in the rest position. Now, rest state. Okay, now this motion normally, when an object is traveling along a straight line, okay, at any instant of motion, I need to know only about if this is the origin. Okay, at any instant of time, I can locate the object by knowing along the x-axis. Only x-axis is required for it. So such type of a motion, we call it as motion in one dimension. Only one dimension is required to explain the position of an object. So now, if an object is moving, okay, and to locate the position of the object, if we need x-axis as well as y-axis, okay, that means 2 dimensions are required to locate the object, like how much it is from y-axis and how much it is from x-axis. This type of a motion, we call it as motion in 2 dimension. That's our next chapter, okay? So, if only one dimension is needed to explain the motion of an object, we call it as motion in one dimension. This is also called as motion in straight line. Motion in straight line. And motion in 2 dimension, we also call it as motion in a plane. Now, if we check the corner of a room, and if there is a fly in the room, you have to tell the position of the fly can be explained only like how much from X, how much from Y, and how much from Z. So this type of a motion, we call it as 3-dimensional motion, or this is also called as motion in a space. Okay, but luckily we don't have this in our syllabus. We have only motion in straight line and motion in a plane. So our second chapter is for motion in a straight line. So motion in a straight line. So this we need to study in detail. So let's see about the position first. Okay, I assume that the particle is at position A. After some time, the position changes to B. After some time, it changes to C. And after some time, it is changing to D. That means continuously the position of an object keeps changing. And this is what we call it as we say that this is the total distance covered by the object. Total distance means it is the total path covered by the object. You get this as AB plus BC plus CD. Okay, you measure this in meters, but there is no specific direction for it. The direction keeps on changing. So this type of a quantity, we call it as scalar quantity. The moment it starts, it will be always positive. Whereas, the distance between the initial position and the final position, we call it as displacement. That is only from the initial position to the final position. And it has SI unit as meter, but it has a specific direction. So it is a vector quantity. So these are the two physical quantities we will study first in motion. What are they, children? They are distance and displacement. Distance and displacement. So now we learn about rate in physics. Rate in physics means rate of change of. Okay? Any change happening in a particular interval of time, we call it as to divide by time. Rate in physics means to divide by time. So, rate of change of distance. What do we call that as? It is distance divided by time. And distance divided by time is another physical quantity. We call that as speed. As it is distance divided by time, speed is a scalar quantity. Okay. And speed, SI unit will be meter per second. Whereas rate of change of displacement, if you take the next one, rate of change of displacement, what do we call this as? This is displacement divided by time. Displacement divided by time, we call it as velocity. As it is displacement, it has a proper direction, and this type of a quantity, we call it as vector quantity, and the SI unit remain the same. So basically, displacement can be called as distance along the same direction, or velocity is speed with the direction. So you can tell that distance is equal to displacement or speed is equal to velocity only when they travel in same direction. When they are in same direction, we can call distance and displacement to be equal and speed and velocity to be equal. Now, you should be aware of the concept of uniform motion. Why do you wear uniform at school? Is to consider you as equal. So, if a body covers equal distance in equal interval of time, equal distance in equal interval of time, we call that type of motion as uniform motion. For example, in 1 second, the body is covering maybe 5 meters. In 2 seconds, the body must have covered 10 meters. And in 3 seconds, it will cover 15 meters. And in 4 seconds, it will cover 20 meters. So this type of a motion, we call it as uniform motion. And if it is unequal distance, we call that as non-uniform motion. This is called as non-uniform motion. For example, in 1 second, if it is traveling 5 meters, maybe in 2 seconds, it would have traveled 12 meters. And in 3 seconds, it would have traveled 20 meters. And in 4 seconds, it must have traveled some other distance of 25 meters. So you can see that they travel unequal distance in equal interval of time. Such type of a motion, we call it as non-uniform motion. So you are clear with the distance, displacement, speed, velocity, uniform motion, and non-uniform motion. Now comes average. Average speed is also there, and average velocity is also there. As you know, speed is equal to distance divided by time. So if it is average, just add a total before them. Total distance divided by total time, we call it as average speed. And total displacement divided by total time, we call it as average velocity. But normally, since velocity has a direction, and if we have two fixed values of velocity, average velocity can be also calculated as average of initial velocity and final velocity, v plus u divided by 2. Now comes the instantaneous values. Remember, children, whenever in physics we call instantaneous, instantaneous, okay, it simply means that at any instant of time, at any instant of time, it will be a very small interval of time, at any instant of time. We have basically instantaneous speed, okay, instantaneous velocity, and instantaneous acceleration. Three things are there. So you should be knowing what acceleration is. So what is acceleration? It is the rate of change of velocity. Okay. So it is nothing but change in velocity divided by time. So what is the change in velocity is final minus initial divided by t. Okay. So all the instantaneous values, we need to take the limit of delta t. Delta t means the time taken for it almost approaching zero. So instantaneous speed is when time is almost approaching zero, delta x divided by delta t. Okay. What is this delta x? Delta x is distance. If it is speed, it will be distance. A limit of delta t tending to 0, delta x divided by delta t, this x will stand for displacement. And what is instantaneous acceleration? Limit of delta t tending to 0, delta v divided by delta t. So instantaneous simply means that any change what takes place in a very short interval of time. And what is that represented as? Change in a particular interval of time. Change in a particular interval of time. In a particular interval of time, we call this operator as d by dt. Change, d stands for change, and dt, the small interval of time. And d by dt of x raised to n is achieved as n x raised to n minus 1. So throughout the grade 11 and 12, you should be thorough with the formula for differentiation of x raised to n dx is x raised to n minus 1. So what is x? 2x cube. 2x cube differential is 2 is constant. X cube differential is n is 3, x raised to n minus 1. So this will be 2 into 3, 6, x 2 minus 1 square. So this is how we do the differentiation. Now, the last thing in this part of the video is regarding the distance traveled in the nth second of motion. Okay. For example, in 1 second, the body traveled 5 meters. In 2 seconds, the body traveled maybe 7 meters. In 3 seconds, it traveled 15 meters. And in 4 seconds, if it is traveling 20 meters, listen to the question. What is the distance traveled in 3 seconds is 15 meters. 4 seconds is 20 meters. But if the question is fourth second means the distance traveled after 3 seconds until the fourth second, we call it as distance traveled in the nth second or fourth second. How much we will get that as? It will be equal to So what will be the distance is 20 minus 15, which is 5 meter. That means distance covered after 3 seconds and within the 4th second. That is what we call it as the distance traveled in the nth second. So how do we calculate this distance traveled in the nth second is, how did you calculate distance traveled in 4th second? Distance traveled in 4 second minus distance traveled in 3 seconds. So distance traveled in nth second is distance traveled in n second minus distance traveled in n minus 1 second. Okay. We are not taking t seconds because it is very difficult to say tth second. Nth second is easy to say. So what is Sn? Un plus half an square minus, what is n minus 1 is, wherever you see n, you put n minus 1 plus half into a into n minus 1 the whole square. This is equal to un plus half an square minus, okay, this is un minus u plus half into a into n square minus 2n plus 1, expanding a minus b the whole square. So this is un plus half an square minus un minus u plus, expand the bracket, half an square, 2 and 2 get cancelled, so minus an plus half a. Now expand the full bracket, un plus half an square minus un, minus into minus plus u, minus into plus minus half an square, minus into minus plus an, minus into plus minus half a. So you will see that un get cancelled, half an square get cancelled. So this is u plus an minus half a, which we can write it as u plus a common out, n minus half. Taking LCM, u plus a by 2 into 2n minus 1. So this is the derivation for distance traveled in the nth second of motion. So the remaining thing in the chapter is related to graph and how to derive the equations of motion from the graph.